Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to absolute value inequalities. And I guess we're looking at 7.2. 7.2. So let's write this down. We've got the absolute value of 16x plus 10 is less than or equal to 46. Less than or equal to 46. All right. Okay, the absolute value of 16x plus 10 is less than or equal to 46. So the first thing we'll do is go ahead and drop the absolute value bars. Remember, this is an AND, okay? Because it is pointing to the left. And when we think of AND, I didn't mention this in the last problem, you should think of intersection. Okay, think of intersection. It's where the two intervals intersect. Right? And let's go ahead and rewrite that over here now. We got 16x plus 10, but this time remember we flip the inequality, make that a negative 46. Alright. Now, what do we got going on here? We're going to go ahead and work this one over here first as usual. So taking that 10 over to the right, we got 16x is less than or equal to 36, and then of course taking the 16 diagonally down over 16. And I got to find out what that buzzing noise is. Okay. Somebody's on the website. I get these Google Analytics push notifications. Alright, never mind. Sorry about that. We got 36 over 16. Just never know. 9/4. So x is less than or equal to 9/4 after we reduce that down. Now let's work on this side over here. So we have 16x is greater than or equal to negative 46, and of course we are subtracting 10 to both sides. Is that what I did here? Yeah, making sure. Okay, and so we end up with 16x is greater than or equal to negative 56. And x is greater than, bringing the 16 diagonally down, and of course we'll want to reduce that down, and what does that reduce down to? Okay, go to negative 7 halves, negative 7, so 4 goes 7 times 8. 8 goes on 2. So that's 7. Okay. Got it. And, wow. What's going on there? We got x is less than or equal to 9/4. So we'll put 9/4 right here. 0 somewhere about here, we'll just say, and then we'll just say negative 7 halves is here. Now remember, we're going to include, we'll look at this one here, we include 9/4, so we want to put a solid dot. We're going to write it up here, okay? And then everything to the left of that, we should probably still keep going. And then let's look at this one here. We'll put the solid dot up here. And x is, well, over here, x is greater than or equal to negative 7 halves. So everything going off in this direction. Okay. Now, as you can see, remember I mentioned the this operation here, set notation for intersection. An intersection meant and. And in other words, when we pick a number, it's got to satisfy both this and this inequality over here. Okay, and we write this intersection Okay, and I'm going to go ahead and do this. Now if we were to look at this guy right here, x is less than or equal to 9/4, and that means that it would be from negative infinity 9/4. You see this? That would be describing this interval here. Okay, and then using the intersection, see that, the intersection, then we would say, okay, by looking at which one are we looking at here? X is greater than or equal to negative 7 halves. Negative 7 halves, I see something that I need to do, refix. So this would be, and first off, I need to write this. This includes it. I'm sure somebody out there was going, well, wait a minute, that should be a bracket, right? So you got negative infinity to 9/4, right? And we got the bracket here, and intersection intersects with negative 7 halves to infinity. Well, their intersection, this can actually be rewritten, and we'd rewrite it shortest way possible, and that would be, we would be going from negative 7 halves to 9/4. Okay, that's actually what we want to write, this guy right in here, which just includes these values right here. You see that? So that would be the more proper way to write that, and not this way. Okay, this is a much better way of writing that. Okay, so negative 7 halves and 9/4. Yeah, and of course there you go. Okay. Alright, we are working right on down the list, getting this knocked out. Anyway, we're here at GoToMath.com. You can come on by, practice that. See you later.